Okay, so we are going to start our class now. So the rest will join us. We are proceeding on with the class. So first of all, I'll start by introducing myself. So my name is Joseph Gitao. I will be your trainer for machine learning. So from machine learning, deep learning to model deployment, and also the introduction to big data part. So today I updated your group description, and if you check here, there is this part that I've added some notes for you guys to check. So we will be using these links that are here to access our course notes. Okay, so you have that in the group description. So the first link that we are using is these class notes, the class notes on machine learning. So you can access them through your website. So it has everything that we will cover from day one till the end. So deep learning, I have some presentations and a collab notebook that we will use for that, but for the rest the notes are here. So if you want to go ahead and read them ahead of me, you can do so. Yeah, so today we are going to have an introductory class to what machine learning is. So we won't have any practical session for today. Sorry for that. So we won't be having any coding sessions for today. We will just be looking at what machine learning is, and we will start with the introduction to machine learning. Okay, so we have the first course link there, so I'll open that and maybe I'll do a brief introduction to what machine learning is. So before I do that, maybe we can have an example. So if let me open something here. Then we can discuss these through some illustrations. And from there you'll get to understand what machine learning is basically all about. So let's assume we had this math class and your teacher said that maybe we have the number 1, then followed by the number 2, then followed by the number 3, then next is what you think would be. And let's say we had the number 3 followed by the number 9 followed by the number 12, then the next value will be what you think. Then here we had the number 4, then here we had the number 8, then here we had the number 12. So let me change this. So let this be 6, then this be 9. So if you were to answer these questions here, so for this first sequence that we have here, so what will be your predicted guess for this last value? So for me, I will say this is 4. And here what will be my predicted guess? So from 3, 6, 9, this will be 12. Then from 4, 8, 12, this will be 16. So what do you notice about these values that we have here? So we have a common trend in between here that allows us to say that the next value we will have here should be equal to 4. Same applies here, and same applies down here where we have 16. So what I can say is machine learning is all about trends. So in cases whereby, let's say we had values such as 4, 20, 29, 30, 49, and I ask you to predict this value that should be next year, so it will be hard for you to like do that. But when we are dealing with machine learning, your computer will be able to like check these values that we have here and understand the trends that are in here and come up with a prediction for these values. So let's go back to the notes. So machine learning is a field of artificial intelligence that involves building algorithms and models that allow computers to learn from data without being explicitly programmed. So what are they learning from your data? So they are learning trends, they are learning some underlying information that in your data that can help in coming up with decisions. So machine learning is important because it enables computers to learn and improve automatically through experience and to perform tasks that are too complex or time consuming for humans to do manually. So it has a wide range of applications in various fields such as healthcare, finance, marketing, and transformation. So it doesn't matter which field you are working in. So there is always a way in which you can apply machine learning. So for example, if you are working in healthcare, so you can use machine learning to come up with a system that can help you diagnose patients more accurately than how you could do it. So if you're working in finance, you can come up with machine learning models that can do things like credit scoring, things like projections, so financial projections and all that. So here we have an example. So machine learning can be used to predict the likelihood of a patient developing a certain disease based on their medical history and other factors, or to identify fraudulent transactions in a financial systems. So it can also be used to recommend products or content to users based on their past interactions and preferences, or to optimize routes for delivery tracks. So overall, machine learning has the potential to revolutionize the way we solve problems and make decisions by automating and improving processes that are currently done manually using traditional algorithms. So let's go to the next part, whereby we will discuss the different types of machine learning models that we have. Yeah, so here we have three types of machine learning models. So we have supervised models, we have unsupervised models, and we have semi-supervised models, so which is a combination of supervised and unsupervised. And lastly, we have reinforcement learning. So we will discuss each in detail and see how they work. So for example, when we talk about supervised learning models, so supervised learning is a type of machine learning where a model is trained on labeled data, so which means that the data has a known output or target. So the goal of supervised learning is to predict the output of new unseen data based on the patterns learned from the training data. So I'll give you a simple example, and this is based on what you've learned so far. So you've covered linear regression in statistics. So linear regression is one of the models we use when we are studying machine learning, and that's the basic model for supervised learning algorithms. Yeah, so let's discuss it. So when you are doing linear regression, so you learned of something like let y be equals to mx plus c. So that's your equation. So what is your y? So your y is your target, so maybe something you want to predict. And what is your m, and what is your x, and what is your c? So m and c are constant values, but I don't want us to discuss this equation as of today. but I want you to understand what is supervised learning. So for example, if we come back here, let's say our y is equals to the amount of calories, okay, and let's say our x should be equals to, okay, so what should be our x? So our x should be, maybe for example, the sugar intake you had in, let's say, ml. Then we can say our c should be equal to a constant number, so let's say maybe something like 10, and our m should be equals to a constant number also, so let's say 1. So if we wanted to calculate how many calories you've consumed in a day, so what will we do? So we will take this equation and say our y should be equal to, let's say you had 10 mLs of sugar, so this will be 10 multiplied by 1, which is our m, then plus 10, so our y will be equals to 20. So we will say that for that given day you've consumed 20 calories, so you've added 20 calories into your body. So what machine learning does is, from past data, so for example we will have 10 records of x, okay, and we will also have 10 records of y. So from these 10 records of y, so our computer would learn the trends that exist here. So for example, for a person who has consumed 10 mLs of sugar, then the calories are equal to 20. For a person who has consumed 20, then this will be equals to 30. So for a person who has consumed 30, then this will be equal to 40, and so, so that if we informed our model, or if we instructed our computer to like predict how many calories does a person who has consumed 80 ml of sugar have, so basically it would say something like 90, because already from the trends that we have here, you can see we are only adding 10 to this value that we have here, and your computer would have learned that. And basically that's what we call supervised learning, so it's as easy as that. Then we have unsupervised learning. So unsupervised learning is a type of learning where the model is not given any labeled data, and the goal is to discover patterns and relationships in the data. Okay, so let's have a look at an example of these. So I'll create a new drawing for this illustration. So let's say we had this circle over here, and inside this circle we had this class here of pink circles, and apart from that class of pink circles we had this class here of orange circles, and maybe lastly let's say we had this class here. So what a supervised learning model will do is it will look at this whole circle, and what it will do is, we have no labels here, so it will come up with these 4 different groups and assign to them labels. Okay, so this will be group 1, this will be group number 2, and this will be group number 3. So we don't know what is in group 1, what is in group 2, and what is in group 3. So what a supervised learning model does is it tries to like look at your data set and go ahead and create these groups, of which we don't know like what is existent in those groups, but your computer will be able to know that these groups that are in here have similar characteristics. So for example, these are orange in color, these are pink in color, and maybe these are blue in color, and so. So basically that's supervised. Unsupervised learning. Then semi-supervised is a combination of the two, so both supervised and unsupervised learning models. Then we have reinforcement learning. So reinforcement learning is a type of machine learning model where we have agents. So if I say an agent, you can think of an agent as being a dog, for example, and this dog will learn by interacting with its environment. So if I say that, I mean that this agent will learn by interacting with its environment, so in order to maximize its rewards. So for example, if your dog is safeguarding your home, if an intruder comes in and the dog is able to like chase that intruder away, so you are going to like reward this dog. But if it doesn't do that, you are going to punish it. So the dog will learn that anytime someone I don't know comes in, I should chase them away, or I'm not going to be rewarded, I'm going to be punished. Okay, so here you can see the agent receives feedback in the form of positive or negative rewards and uses this feedback to learn the best actions to take in different situations. So example of reinforcement learning include autonomous robots and game playing agents. So each type of learning has its own unique characteristics and applications, and choosing the right type depends on the nature of the data and the problem at hand. So during our practical sessions, we'll get to see how we apply each of the models we've discussed there. So let's look at the last thing we are going to look at for today, and that is the common applications of machine learning. So here I've listed 6 of them. So first of all, we have in healthcare. So machine learning can be used to predict the likelihood of a patient developing a certain disease based on their medical history and other factors. Then we have finance. Machine learning can be used to identify fraudulent transactions, to predict stock prices or credit risk, or to optimize trading strategies. Okay. Then marketing. Machine learning can be used to personalize recommendations to users based on their past interactions and preferences, or to optimize advertising campaigns based on target audience and performance. Then we have transportation. Machine learning can be used to optimize routes for delivery trucks. Then natural language processing. Machine learning can be used to analyze and understand human languages, which has application in speech recognition and all that. Then computer vision. Machine learning can be used to analyze and interpret images and videos, which has applications in object recognition, facial recognition, and automated surveillance. Okay. Yeah, so that's it for today. So not unless you have questions. Any questions from your side? Based on what we've discussed. So those who have joined late, I have informed you that from the group description you can access these notes, so they are here. So there is a link that I've added in the group description, so class notes, and that has all the notes that I am looking at here. So we won't look at the machine learning cheat sheet for today because we haven't gone into the practical part yet, but once we've discussed the practical part, we will come and look at these and understand what is in here. Yeah, so basically that's all for now. Any questions? Hello.
Good evening.
Good evening.
Just an inquiry. Machine learning, is it like a combination of all the past programs that you've learned?
Yeah, so machine learning requires you to be good at the other things you've learned, so especially the basics of Python part. But I guess
Okay.
there is a way. Yeah, but it requires you to be good at what you've learned in the basics of Python class.
Okay.
Yeah. Any other questions?
Thank you.